Okay, so we are starting another video. This one is going to cover how to graph cubics, x3s. So we're just going to go ahead again and get started. As I've told you before, it would be my suggestion that you do a couple of things. One, as I ask the question, I will pause a little bit. I would suggest you pause the video and try to answer the question on your own. Don't wait for me to answer it, then go ahead and play the video and see if you got it right. Again, guys, the only way you're going to know if you can do these problems on your own is for you to actually work it. So if you'll work it prior to me working it, answer the question, see if you know the question, and then again, play the video and see if you got it right. If not, what did you do wrong on that? But if all you do is just watch me do it over and over, you're not going to know if you can do it on the test. The other thing that I would say, which you're not going to hear me if you have the sound off, but is to have your sound on, because I do say things, a lot of things, that are not written down. I verbalize them to you. I don't write every little step down, every little comment down. So unless you have your captions on and you're really reading your captions closely, you're not going to hear everything that I say. So let's get started. So the first one here is, what is the degree of this polynomial? Okay, it is a 3. I already told you that. That's called a cubic. Okay, you do need to know the name of it. The next thing is what are the number and the type of possible solutions, roots, intercepts, zeros. Those all words mean the same, but what are the number and types of possibles? Okay, again, this is where I just make my little chart because I think that's easier for me to understand. Do you have to make a chart? Nope, you don't. But you do have to, in some way, organize your information that you're given to me. So since this is a 3, we know that we could have a max of 3 real solutions, a max of 3 x-intercepts. So again, a quick sketch of that graph would be where it looks something like that. Okay? Now that means that it has 0 imaginary. Our next option, and again, sometimes it's easier to come from this side because we know imaginaries come in pairs. So my next option is that I have 2 imaginaries and 1 real. Again, that one looks like that if I sketch it. So I only have this one spot that crosses. It doesn't cross on the other side. Okay, now that's going to be our only options that we have for a cube. Okay. So the next question is, what are the end behaviors for our graph? Okay, so again, I've kind of given you a sketch, so that should help you out. Again, how we write that, as x approaches a negative infinity. So what I'm saying is, as I'm going this direction on the x-axis, what's the y doing? Well, it's going down. So as x approaches a negative infinity, y approaches a negative infinity also. Our next is as x approaches a positive infinity. In other words, as x goes this direction, what's your y doing? And we see it's going up. So y approaches a positive infinity. Okay, so those are my end behaviors. Again, I mentioned earlier, mention it again. Anytime we have an odd power, these will always be the opposite of each other. Remember on our other video, we said if it's an even, those are the same. Okay, next question. What is my y-intercept in this equation? Okay, and your answer should be that it is 0, -8. Again, if I put it in function notation, I'm looking for where f is 0, f of 0, I should say, and I would put that in, and you see the 0 cancels, and I get f of 0 is a negative 8. Okay. Our next piece is to just jump right in and find our, again, roots, 0, x-intercept solutions. We've talked about those all mean the same on there. Roots, zeros, and x-intercepts are used more when we're graphing. If we're just solving it and not graphing, we use the word solutions. But they all mean exactly the same thing, okay, in terms of how we get that number, same thing. So, again, you have your two choices. They are to factor or synthetic division. Now, can you factor x cubed minus 8? And the answer is yes, you should be able to factor this. So this is your difference of cubes that we have done when we were factoring. We were learning all the different forms of factoring. Difference of cubes was one of those. There was a set rule that you had to remember on how cubes factored. You may or may not have that handy that you could just pull that out. You may have it memorized already, which is what you were supposed to do. So factoring is an option, definitely. Could you do synthetic? 100%. You could do synthetic. So I'll actually set it up and show you the synthetic also, because I know from comments in class that a lot of you have not memorized your difference of cubes. So when I go to do cubes, 1 is 8. I could rewrite this as 8 is 2 cubed. So your rule says to take the cube of each of those, so that would make x minus 2. Your sign, if it is negative here, will be negative there. The next step is to take, and your first number in this, or the first letter in this case, would be x, and I'm going to square it. I change the middle sign, so it now becomes a plus. I multiply the 2 and the x, and then I square the last number. Okay? And that is your factored form. So we are looking for our zeros, so we want to know when that equals 0. Well, this one is going to be x equals 2. The other part, if you remember back when we did the cubes, I specifically told you this second piece will never factor, never. So you need to run the quadratic on it. Or it could be imaginary. So let's do a quick b squared minus 4ac. So that would be 2 squared minus 4 times a times c, which is 4 minus 16, which is a negative 12. So this piece is going to be imaginary. Okay? Which means in terms of my box up here, this is the one that I'm looking at. 1 real, 2 imaginaries, which means my graph should look something like that. Ballparkish. Okay? So, let's go ahead and I'm going to back up and show you just real quick synthetic division. I'm not going to run the whole thing, but I'm going to set it up for you. So synthetic division, we have x cubed, which is 1. There's no x squared, there's no x, and there's a negative 8. Okay? Now, again, you would use all the factors of 8. 1, 2, 4, 8. I'm going to go ahead, since we know 2 works, just show you. So multiply, add, multiply, add, multiply, add. Okay? So maybe you like that better. I don't really care which way you do it, as long as you get it done. Okay, so we're going to go graph. I know my y-intercept, right? 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I know an x-intercept at 2. Okay? And I know my end behaviors. So I know this is going to go up here somewhere and down here somewhere. Now, this one's kind of tricky because of the fact you don't know if we're going to see a hump kind of over here, because there definitely could be a hump, or if there is going to, when we come here, possibly a hump. We don't know. So really, it's kind of your call where you want to put it. One of the things that you could always do is try a number. Okay, so we could come in, and I've told you that, guys. If ever in doubt of what a graph looks like, make you a t-table and plug in some points. T-tables work all the time. They are not necessarily the best. Sometimes they are not perfect, but they will work to at least get you a sketch. So I might put in, let's say, a -1 here, just to see if it does go back up or if it goes down. And so again, -1 cubed minus 8, so that would be a -1 minus 8, so that's a -9. So what that means is my graph is now at a -9 right here. Okay, I could put in another number. I could put in a -2, okay, which would give me a -8, which now I'm at a -16. So from that information, it is very clear to see that at a -2, I'm all the way down here to -16 somewhere. Put it right there. So it's obvious that I'm really not going to have a hump on there. So this is going to come up through here and then up through here. Now, again, I could check. So I could go to 3, because that would be this point, right? And I could check to see what happens at 3. Let me clean that up a little bit. So that would be 3 cubed minus 8. 3 cubed is 27, right? Minus 8. So at this point, I am up at, what is that, 19? So there it becomes really obvious that this goes on up. So I'm way up here at 19. Of course, that's not 19, I know that. But I'm at 19. Whoops, sorry about that. Didn't mean to hit that. So at 4, think about it. If I put 4 in a cubit minus 8, it's going to keep going. So what this really means is that I don't even have a little hump at all. It's just going to go. Okay? So it's going to look like your standard x cubed graph. Okay? And again, so if ever in doubt, just throw some points in there and kind of get an idea of what it looks like. Okay, so again, that is your x cubed. Okay, we're going to do another x cubed real quick. So I didn't put all the questions here, but we will put them as we go. So the first one is, what is the degree? So we'll also talk a little bit about points. That would be worth 1 point. And this one is what degree? Okay, it is degree 3. Again, it's called a cubic. The next would be, again, to state the possible roots. And type. So I'm going to expect you to do, again, not necessarily a table, but organize it. So you're going to get the 3, 0, 1, 2. Guys, that's always the same. Always the same. So in this case, if I'm looking at point values, that would be worth 2 points that you state each of those. C is your end behaviors. Again, since it is a cube, x approaches negative infinity, y is going to approach a negative. As x approaches positive, y is going to approach a positive. Again, remember these two are just the opposite. Our next one is our y-intercept. So in this case, x is 0. We're going to get 100 definitely you're not going to want to probably put that on your graph. E is, again, to find the roots. I want you to actually find them. Now, in this case, we could look at it, and again, will it factor? If not, we're going to be looking at do synthetic division with the factors of 100, which would be 1, 2, let's see, 3, 4, 5, 6, 7, 8, 9, 10, so forth. Okay, you're going to have a lot of factors there. And so we would run our synthetic 1, 4, 25, 100. Okay? Now, some of you might look at it and say, well, I think it might factor. So if I come in and I do a grouping, is it possible to factor? So out of the first set, we could take out, I'm going to put this down. I'm going to just rewrite it down here. So again, guys, if you honestly, when you're doing these, never have to factor, okay? You can just do synthetic division the whole time. But some of you might like to factor. You might say, hey, factoring's easier. So again, I'm grouping, and I'm grouping. I'm going to take out an x squared. That's going to leave me with an x plus 4. And on this one, I believe I can take out a 25. Okay, so what would be your final answer here? And it would be x squared plus 25 times x plus 4. Okay? Okay, and so we're going to set again those equal to 0. So x plus 4 equals 0. That's going to give me a negative 4. And x squared plus 25 equals 0 is x squared equals a negative 25, which is an imaginary number. Okay? So let's go to our graph because we pretty much got everything we know. So we know that our intercept is at 0, 100. Okay? So that's like so far up here, we don't want it really on our graph. Okay? We also know that our x-intercept is at a negative 4, and that's all we know. Okay? We know it's a cube, so we know it's going to do that. We know it is going to go through this point, and we know it's going to hit up here at 100. Again, I don't really know what's going to happen between a negative 3 and 0. So what you might want to do again is put in a t-table, and let's say, okay, what would happen at a negative 2? Okay, and so I would go up to my problem and put in a negative 2. And what I'm looking for is there a kind of a hump in here? In other words, is it going to do something, hump and then go back up? I really doubt it will, but it is possible. So that's what I'm checking for. I'm checking to see if it's going to keep going up or going to come back down. 25 times a negative 2 plus 100. So this is a negative 8. This is going to, negative 2 squared is 4, times 4 is 16. This is a negative 50 and a plus 100. So add that up. So I get 8 minus 50 plus 100, which is a negative 42 plus 100 would give me 58. So at a negative 2, I am up at 58. Okay? Which indicates to whoops, I didn't mean to erase that. Okay, which indicates to me that if I'm at a negative 258, if 100's way up there, I know this is not to scale, but that it is going to probably just keep going, okay, in some fashion. Now, there's got to be probably some kind of a little curve in there. we're not really going to know where it's at unless we put more points in there. So again, I would probably go ahead and choose like a -1. I would also probably choose maybe 1 just to get me a curve in there to see what it's doing on there. So let me get that back straight. Okay, so again, let's just do this a little bit better. Okay, so what I'm going to, whoops, I didn't mean to erase all of that. I just really erased everything. So let me just redraw this real quick for you. I'm going to do a different scale just so we can kind of see what's going on here, because that one does look a little funky. So I'm going to go by, let's go by tens. Okay, so 10, 20, 30, 40, 50, 60, whoops, I can't count. 10, 20, 30, 40, 50, 60, 70, 80, 90, I think that's 100. My eyes. 2, 3, 4, 5, 6, 7. Oh, that's 9. Okay, let's get one more. Okay, right there. And then we said at a -2 was at 58. So 10, 20, 30, 40, 58, somewhere right there. And then I'm still going by ones across here because I don't want it. So this is still at a -4. There we go. So let's put in, let's go ahead and put in, what do we want to put in? Let's put in a -3. Let's just see what happens at a -3. So -3 plus 4 times a -3 plus 25 times a -3 plus 100. Okay, so I've got a -9 plus 12 minus 75 minus 100. So this is going to give me 3 plus 100. So a -72 plus 100. So that is what? 18? 18? Yep. So at -3, I'm only at 18. Right here. Okay. So there's where you can see that now. You can see that curve coming in. Okay. I'm not to scale. But again, there's that curve. So it does kind of look like that normal curve that we have. It's just we got weird numbers. Okay. There you have it. So that would be, again, your x cubed. So that is one that you could do by grouping, or again, you could do by the synthetic division. And since I knew -4 worked, we'll just do a quick check. Yep, it did work. Okay, so you could have also done that. Either option, it doesn't really matter. I'm good with either one of them. Okay, that is, again, your second x cubed.